In today's session, we're going to have a look at pictograms, see how to interpret pictograms, and that will of course help us in drawing pictograms ourselves. Okay, so in pictograms, they are another way of visually representing data, but in a pictogram, pictures or images are used to represent the frequency. Let's have a look at an example. Okay. So in this pictogram, you can see that it shows the number of DVDs in a collection, and they're separated into different genres. We have so many action DVDs, so many comedy, so many sci-fi, so many drama, etc. The very important bit to notice is the key over here. Every pictogram has to include a key, because what this is telling us is that one image, one disc, one DVD represents 4 DVDs in terms of frequency. So if I was to look at sci-fi, it's represented by one disc. Therefore, that's telling me the frequency of the sci-fi genre, there is 4 DVDs. We also need to take a little note at this half image, half of a disc, half of a DVD. So if a full disc represents 4, you would expect half a disc to represent 2. You may even get some questions when a quarter of the image is visible, and then you'd need to work out what that represents. So if I wanted to ask how many comedy DVDs were in this collection, it would be 4, add 4, add 2, so the comedy frequency would be 10. Let's have a little look at some questions. How many history DVDs are there? Well, there are 6 discs, 6 images, and they each represent 4. So we could do a little multiplication, 6 times 4. Alternatively, we could do an add. 4, add 4 is 8, add 4 is 12, add 4 is 16, add 4 is 20, add 4 is 24. If we did the multiplication, we'd come up with the same result. So there are 24 history DVDs in this collection. How many action DVDs are there? So this time we have 3 full discs and a half disc. So if we did the addition, it would be 4, add 4, add 4, add a 2, which is going to give me 14. Alternatively, I could do it as a multiplication. I have 3.5 discs. Each disc represents 4 DVDs. So if I do a multiplication, there are 14 action DVDs. Question 3. There are exactly 16 DVDs in which category? Okay, so if we're looking for 16 DVDs and we know one disc represents 4, 16 divided by 4 gives me 4. So I'm looking for the category which is represented by 4 full discs, which looks like it will be the drama category here. 4, 8, 12, 16 drama DVDs. So we do a little division and we're looking for the category with 4 pictures, which is drama. Question 4, how many DVDs altogether? Okay, so there's a couple of ways to approach this. We could work out individually the frequency of each genre and then add them together, or we could add up all the discs combined and multiply them by 4. Remember, if we've got a half disc here and a half disc here, we could put that together to give us one full disc representing 4 DVDs. So there are 17 discs altogether. So we've got 16 full discs plus this half and a half, giving us 17 full discs altogether. Multiply them by 4, basing that on the key. It's going to tell me that there is 86 DVDs represented in this complete pictogram. Okay, so there's my first example. Just remember that in a pictogram, pictures are used to represent frequency, and we need to be aware of half images representing half of what the key is worth, or even potentially a quarter of an image or a third of an image, depending on how complex the pictograms become. Let's have a look at another example. This pictogram shows the favorite maths topics of students in a class. So you can see some students liked area, some liked fractions, some liked angles, some liked ratio, and some preferred percentages. If we look at the pictogram key, we can see that each image, each hexagon represents two pupils. I could have picked any little image, any picture to represent two pupils, but we just try and keep it slightly related to the topic. When you come to draw your own pictograms, you will be picking the image and then you will be deciding how much it represents. When you do a pictogram, usually your key would be greater than 1, because the advantage of a pictogram is that we can reduce the length of these bars. We can reduce the size of the pictogram by making one image worth two or more things. So for example, in this example, the image is worth 2 pupils. In my previous example, the image was worth 4 DVDs, which shortened the length of the pictogram. So an advantage of a pictogram is we can reduce the size of the image just by ensuring the key equals greater than 1. Usually that is what you would aim for. Okay, let's have a little look. How many pupils preferred area? Okay, so we look at the area section of the pictogram. We can do an addition. 2, add 2 is 4, add 2 is 6, add 2 is 8, add 2 is 10. Alternatively, we could do a multiplication. There is 5 images. Each image represents 2 pupils. 5 times 2, 10 pupils said that their favorite topic was area. Question 2. Which 2 topics are equally popular? So we're looking for 2 topics which are represented by the same number of pictures. So if we look over into the pictogram for angles, we've got 1, 2, 3 images representing 6 pupils, and percentages, we also have 1, 2, 3 images representing 6 pupils. So we can say that angles and percentages are equally popular. There is 6 students who prefer angles and there are 6 students who prefer percentages. How many pupils preferred fractions? So this time we're dealing with a half image. So we've got this full image representing 2, therefore half an image will just represent 1 pupil. So for fractions, we could do an addition, 2, add 1, giving me 3 students. We could also do a multiplication, 1.5 images multiplied by 2 pupils also gives me 3. Question 4. Which was the preferred topic of exactly 5 pupils? Okay, so this time we're trying to think of how 5 pupils would be represented. Well, if 2 pupils are represented by a full image, 2 images would represent 4, 2.5 images would represent 5 pupils. So each picture represents 2 pupils. So if we took the 5 and divided by 2, we would end up with 2.5. So we're looking for 2.5 images, which is represented here. Ratio represented by 2.5 images, 2 pupils, 4 pupils, and an extra 1, 5 pupils. Okay, so let's put some tasks on the screen for you to have a go at. So you can see task 1. I've presented some data in a frequency table on the transport that people use getting to school, that students use getting to school. So you can see 6 students walked to school, 10 students took the bus, 4 students biked, and 3 students took the car. Remember, at this point you have the ability to pause the video I would like you to pause the video and produce a full and accurate pictogram representing this data here. Would you like to pause the video now? Okay, welcome back. I'm going to show you one example of a pictogram. Okay, so my solution looks something like this. Of course, your pictogram may not look exactly like this. In fact, it probably doesn't look exactly like this because you may have chosen a slightly different image and you may have chosen a slightly different key. You may have used a bicycle as your image and you may have had each bicycle representing two people. So your pictogram may look different to mine, but if it is reflecting the frequencies accurately, then you've done it correctly. But this is just one example of what your pictogram could look like. Notice the important points. I have got a key and the key represents 4 people. The important bit being that it represents more than one student. Okay, so then I've represented walk by 1 full image and 1 half image. 1.5 times 4 would represent the 6. For bus, 2.5 images times 4 represents the 10. For bike, we have 1 image, which represents 4. And for car, we have 3/4 of an image, representing 3. Because of this 3/4 image, you may have used the key to represent 2 people, which would mean that you're not in the need of a 3/4 image. Everything could be represented by full images and half images. Also notice that I've put a title on my pictogram to ensure that it is completed accurately. Okay, task 2. So you can see from task 1 that your pictogram may not necessarily look like mine. However, I will again show you how I approached the question. But if you could pause the video here and take the information from this frequency table about types of pets and present them in a good and accurate pictogram. Could you pause the video now, please? Okay, welcome back. So we're now going to show this data in a pictogram. My answer looking like this. Again, I've shown a key, vitally important, and each image, I've used a fish as my image, represents 4 people. Your pictogram may not necessarily look like this. You may have used a different image. You may have used a dog, a cat, a smiley face, a goldfish, a flower, any sort of image, and you may have said that your image was worth 2 people or 3 people or 6 people. I've used 4 people. So your pictogram could look different, but it has to be accurate and reflect the data. For example, the dog frequency was 16, so I represented that by 1, 2, 3, 4 images, 4 times 4, associated with this 16 here. For hamster, we've got 1.5 images, 1.5 fishes, 1.5 times 4 is associated with this 6 here. Again, a little title across my data to give it some context. Okay, so this is task 3. I would like you to look at this raw data this time, and I would like you to put it into a table and then a pictogram. So you need to present this data in a frequency table. You may also use a tally chart if you think it's going to help you for this question, and then present your data, your information in a pictogram. Would you like to pause the video here and have a go at task 3? Okay, welcome back. Let me show you my pictogram. So again, I've got a key here. This time I've went with 1 shoe representing 2 people. For a shoe size of 3, we've got 1, 2, 3, 4 people had a shoe size of 3, which is why it's represented by 2 images in the pictogram, 2 times 2 representing 4. Remember that this data would have been a lot easier to work with if you'd used a frequency table and possibly a tally chart to get your totals. Notice that there's no size 9s in the data, which is why I have a gap here with no images at all in the pictogram. You may have went ahead and used your key with one shoe representing 4 people, in which case your pictogram would look different, but as long as it is accurately reflecting the data, then it is correct. Again, title included to give some context to the question. Okay, can we have a go at the final task, task 4? Can you take the information from this bar chart and place it into a pictogram? The bar chart shows the amount of text received per day by somebody. We can take the frequencies from the heights of the bars. So you may want to display this data in a frequency table, or you might just want to take the frequencies directly from the bar chart and place it into Pictogram. Could you pause the video at this point and have a go at task 4? Okay, welcome back. Let's have a little look at my final answer. Okay, I've went ahead with an image of a mobile phone representing 2 people. You've probably chosen a different image, I'm not sure. You may have had your image representing 3 people or 4 people, but I felt that 2 people was appropriate for this question. I've included a title of text received to give some context to the information. If I look at Tuesday, you can see that the frequency for Tuesday was 6, which is why it is represented by 3 mobile phones. 3 images times 2 represents a frequency of 6. For Saturday, the frequency, the height of the bar is 10, so that should be represented by 1, 2, 3, 4, 5 images, 5 times 2 representing a frequency of 10 for Saturday. Okay, if you have been able to produce 4 good accurate pictograms and each of your pictograms reflects the data and the frequency you were given, then that's brilliant. You've shown some very good understanding of drawing and interpreting pictograms.